Good morning. Good morning.
Good morning, Lee.
Good morning, Ryan. You're the lucky winner today from multiple perspectives.
Oh, really?
Oh,
Oh,
yeah.
care to elaborate?
Yeah. One of those perspectives is it is what time is it for you? It's 8 you're it's the
8,
early, yeah.
8 a.m. here. Yeah. Normally I'm still in the bed in bed.
And
But
yep,
yeah,
that's the
that's
first that's the first way in which you're the winner.
okay.
Yeah.
What's the
Uh,
second way?
yeah, say it again, Ruth.
What's the second way? The second way, yeah.
Yeah, the second way is that, well, he gets to bless us with some knowledge today. Mr. Zhang is going to share on, well, he's our first topic. So I won't spoil the surprise, but we'll get into that. So let's see, all right, fair enough. We're a few minutes after, and so some housekeeping items. Um, Everyone on the call should have access to the doc. If you don't, just just make a comment in the chat, and we'll make sure that you do. Um, if you will, list down your name in the attendees. A couple of notes. Hey, we record our community meetings and post them on YouTube. The community meeting minutes are a community effort. So much like everything else we do around here, please jump in. A couple of quick announcements today. So next week, next Friday, we won't meet because that's Christmas. That's the 25th. So Merry Christmas all. Also, we had a number of people newcomers join this week. And so very happy to have those folks. I wonder if we captured everyone. Shriti, was there a Joshua that joined? I thought we did.
Not this week.
Okay. Okay. And then there's a couple of topics that we're going to cover today. If you have topics, now is the right time to list them down. So feel free to call them out and we'll get to them. Yeah, so there's a few things today. Okay, fair enough. Josh, it's nice, or not Josh, Ryan, nice to have you with us. Ryan, do you want to, there's a tradition here. Anyone who's on one of the calls for the first time, they get to introduce themselves, and you're going to do that anyway. But do you want to give a brief introduction, and then maybe we'll sort of roll into talking about OAM?
Sure, definitely. So hi everyone, I'm Ryan, and so I'm in the past year I've been working on the project called OAM, which is loosely speaking, it's application layer definition or abstraction standard that we are working on top of Kubernetes. And its goal is actually more than Kubernetes, but most of the implementations now are under Kubernetes. And I've been working in, so I'm working in Alibaba, and I've been working in Alibaba Cloud for the last about 4 years. And before that, I was in Twitter.
Nice.
So it's nice. I heard of Layer5. I accidentally bumped into Lee with a Google student, something like that, and Lee was really accommodating me as a mentor, which but I didn't really take advantage of that chance. So it's exciting to come to learn what's going on in the mastery world, and see if there are any collaborations that we can forge after this call.
Nice. Hey, Ryan, I'm excited about this. I'm both, yeah, I guess for more reasons than I was thinking of. One is potential collaborations. I think that there's a lot of merit to the vision and the goals of OAM. But then, yeah, also, well, we just, one of our, well, we've got, I'm not sure, we've got somewhere north of 5, but less than 10 interns happening right now, or internships, which is to say, if that continues, if that remains a point of interest to you, like, hey, they're going on all the time, or potentially as we explore collaborations, it might be, we might be able to spin up one in and around OAM. And so,
yeah, that'd be great. Yeah, if we have some interns that is interested, we can explore some opportunities, do some POCs, and see how that works.
Nice. Oh, fair enough. Well, Ryan, I'm gonna stop sharing and let you.
Okay.
Introduce us.
So, how much time do I have?
As much as we can. There's so much going on in this community that we can talk about. It'll take us 2 hours to cover we're not going to cover all the rest, so that's fine. So take as much as it takes to do a complete, a complete picture.
Okay, so maybe I'll take maybe 30 minutes. I'll try to keep that within 30 minutes. And if people here are really interested, we can continue to discuss. Let me just give a brief introduction first. Can I share my screen?
Yeah. So.
Let's see. Which one is the one? Okay, let's see.
Ryan, remind me, Ryan, you're in the northwest of the US?
Yeah, I'm in Seattle.
Okay. Oh, very good.
Wow, it asked me to. So this is a new laptop. It asked me to quit and rejoin before I can present.
Sure. Yeah, been there.
So I'll be back in a minute.
Cool. All right. A little bit of context for everyone else on this topic that Ryan's going to present on. Some of you have spent some time around service mesh performance, around SMP. That specification, it characterizes how to track the performance of a service mesh, and it's made up of it's a specification, so it's just proto files, or it's protobuf files, or it's YAML, if you will, and as part of describing how well a service mesh is performing, well, that's dependent upon what workloads you're running, what applications are you running on the mesh. Okay, well, maybe you need to describe what those are, and OAM does just that. So that's why.
Okay, I'm back. Can you hear me?
Yep, there he is.
Okay, let me try to share my screen again.
Wow,
can you see my screen now?
It's demo time already. I love it. You just jump right to the. No, I'm
okay.
Right,
I see. Okay. Let's see this. Where's the? Make it easier way. Oh, okay.
Oh, very good.
Okay, so I kind of recycled another presentation here, and just bear with me, and I will go through most of the PR stuff quick. So This talk is mostly about running the next generation of cloud native applications. This is our kind of our goal of the open application model. I guess along that line should align with the layer 5. That's for the future generation. And the next slide is so this is for I'm not 100% sure if layer 5 works mostly on Kubernetes or it also works on different runtimes. For us, yeah.
No, I'm sorry, Ryan. Please continue.
No, it is a question. Yeah, it is.
Heavily focused on Kubernetes because of such a focus for us on service mesh, and that's where most folks will start their service mesh journey, understanding that there are many, most of the world's workloads are outside of Kubernetes at the moment. But so anyway, we start there, but the intention is to focus on VMs and workloads outside of Kubernetes.
So. Oh, okay, cool. So yeah, again, that align with our vision too. So we start with Kubernetes, and I think we are working on the next generation of this application model to work more generically on any runtime. So for this talk, it's mostly focused on Kubernetes, and demo is on Kubernetes. And so we know that Kubernetes is not built for applications. For anyone who know Kubernetes, it's pretty clear. It has the concept of basically deployment, stateful set, daemon set, these things. Those are not applications from anyone who has written applications. And but unfortunately, in our community, like the so-called cloud native community, you can see pretty much people take deployment as applications. Recently, we've seen a whole bunch of so-called platforms, application platforms. Like, I don't know if you've heard of that. Like, there's Waypoint, there's Shippa, there is Rio. We're looking to that. It pretty much everybody say when they say allow you to run application, it's a deployment. But that's not the end of the story. And from the developer's point of view, we want microservices. We want to run RPCs, all these things. It's not clearly reflected in the Kubernetes world. It's just the nutshell of this slide. And so current solution is just as I mentioned, people because Kubernetes is so developer unfriendly. We built many teams, independent teams, or some so-called platform teams in big companies or medium companies. They build their own platforms to serve their developers. That's a very common pattern. So they build this thin layer of. Can you see my mouse or cursor? Right.
Yes.
They built this thin layer of application platform, which kind of we call it PaaS, loosely PaaS, that expose different, like really developer-friendly concepts outside. And from the dev side, there's like from source to image, CI/CDs. From operational side, there's capacity management, rollout, logging, all these things. These are like pretty much, if you look at 5-6 different platforms, it's pretty common there. And it mostly works. Like otherwise, they would not have those products. And the user experience, as far as I've tried, varies, but it's okay for developers. But the big problem for us is it's mostly customized, right? The platform builders, they build this user-friendly or developer-friendly platform, but it creates its own UI and creates its own APIs, basically, if you look at most of them. And we know that in the Kubernetes world and the cloud native ecosystem, where you put it in a more marketing word, it has way more capacities, and the ecosystem is huge. Pretty much every day you hear different projects come up and new things come up. So how does the platform building team try to incorporate that without having to rewrite their systems? Basically, don't lock into their existing APIs. So this is kind of our goal. So we have this application model so that it's standard, so that it can allow application builders. So there are actually two parts. The one part is allow platform builders to build developer-friendly application platforms, but also very extensible. So in the sense that it's not tied up. I will show that. That's where the demo comes. It will show how do we make it work. That instead of having a logging API, proprietary API, we give you a very extensible platform that pretty much you can incorporate anything. That's why I think the layer 5 or any mesh service would work here, because we are very extensible. It should be really easy to incorporate that. Yeah, so it's a design for platform builders. I mean, one part it is. Another part is we actually also realized that we want to have a more developer-facing part. So so let me just focus on platform builder first here. So we have the reason it's great for the platform builders. It's allowed platform builders to build a framework that allow them to bring their own workloads. That's the key. That, for example, you can bring in your own. I don't know if you've heard of that. In the you can bring your own workload in the sense that you can put a service, just really basic ones. You can put a service and deployment together and make it a microservice, so that your application would automatically have this service. And also you can put in an ingress. You can do the basic plug and play, and kind of encapsulate that into your own workloads. You can define each workload's own characteristics and the capabilities. And by doing that, all you need is basically get all the put in a real technical term. I mean it's like controllers. You can group a few controllers together and expose them without writing any code, and make them a workload. And also another thing is most of the application platforms currently I've seen don't really focus on or pretty much ignore the operational traits of the workload. Say you have to expand, you have to do metrics, you have to roll out, upgrade. Those are not really reflected in the system yet. In our system, we have it's called trait systems. I'm not sure if the trait, this word is intuitive enough, but you can think of it as basically day two operations. So it's not just the application you deploy that. You have a day two operation characteristics that you can describe. So you can put on a rollout, you can put on HPA, you can put on routing, like which way the HTTP to service routings. So that's what we think is. We're still trying to get the balance between the extensibility and abstraction. That's why it's in a still working progress. Yeah, that's about it. And eventually, this is really a very the reason because we have this trade system, that makes it a lot easier to build a so-called serverless platform, because basically the server part is the operations. So without any manual interaction with the server, you basically can make it very easily a serverless platform, because all the operations are described in the trade system. So in an ideal world, all you need is just apply a trait, and all the operations are done for you. Any questions? I think I kind of covered a lot of ground in a relatively short period of time. And if any of you have any questions, don't hesitate to interrupt me. I'm really happy to explain things.
Ryan, a couple I'll toss in right now, which is
sure.
the PaaS serverless platform. That aspect, I probably missed what you were just saying. Is that characterizing OAM as for teams that are doing serverless things, or is that characterizing OAM as taking on characteristics of being somewhat serverless itself?
Yeah, good question. So yeah, let me clarify a bit here. I know it can be confusing. So OAM is an abstraction standard or application standard. There's implementations. So with any platforms that takes on this abstraction or standard, it will be very easy to build a system that is a serverless platform. So OEM itself is not any implementation; it's just a standard. But any platform builder that adopt this standard will make them very easy to build serverless platform, build platforms that are extensible and still with the good amount of abstraction. That's our goal. And to make it clear, we build our own platform based on OEM to demonstrate how easy it is to build.
Nice. Okay.
Yeah. Because just talking about abstraction is not very exciting afterwards. So
yeah.
Any other questions? Good question. Yeah. Any other questions from anyone else? Or by the way, do you call yourself like Mashery, or it's
the other one, the Layer5. So yeah, you're right that Layer5 is a community of open source contributors that have a few different projects, maybe about, depends on how you count them, but Meshery is the biggest project, or the longest living, and has gone on for some time. Meshery itself, because of part of its focus, it has produced or conceived a spec as well, not complementary to OAM, which is in part like part of the considerations that we might chat about after this is how that spec and this one can potentially complement. So
okay, cool. Okay, so here's some kind of architect of how we envision an OEM platform would look like. So this is a real implementation. OEM is a standard, so it's an implementation of the standard, what we would envision. So in the front there's the UI part that this is basically the real developer facing part, and we don't actually have any specs on that. So you can see I think the orange part are the ones that are not really part of the OEM spec. So this is part that you can, it's platform dependent. But in the center, the core part is this OEM runtime. This runtime would have the controllers. Basically, you have application configuration. That this is how we describe an application. This is how we think an application would look like on Kubernetes or any other platforms. And components are basically the real application. Individual, if you talk in terms of microservice, it's basically individual services. And the most interesting part is this part. We have the capability registry, or we call it capability centers. That's where the power of OEM, any OEM based platform is, that you can register your workload into those. It's kind of like you think of that the Docker Hub, any Java Maven, right? All these things. So if you have that, any platforms builders can basically get their workload from the registry. They can register their own workload. They can get workload from others. They can get trade from the standard hub, basically, and then they can install that into their platform. Now their users can easily use all these workload and trades and build up their applications. And that's the main idea. Again, I think it might be a little bit abstract. I'll show you the demo if it works, and then you will see what I'm talking about. Yeah, on top of that, you can also build a GitOps. You can build a Flux. Basically, you have this pipelines, CI/CDs, all these things. The possibility is basically endless. And here is the platform builders. This part is this. So every platform, we notice that you need this logging, monitoring, and some maybe auditing, scaling. Those are the capabilities. That is part of the traits. Those are actually all traits. So maybe this graph is a little bit confusing, but those are actually part of the traits. So the platform builders, you can, to differentiate yourself, what you need to do is you either put your capabilities into this hub, or you can create your own hub, or just because it's your logging solution is so good. Maybe that's your technical advantage. you can make them your own traits and make it private. So other users can only get this perfect logging experience on your platform. And but that's still part of the traits. Again, if anyone has any questions, feel free to ask. Okay.
Like I had,
Yeah.
like it can be a silly question. Sorry.
No,
So
no,
like,
mhm.
yeah, I just wanted to ask, like, is it something of like a specification template generator for cloud native applications, or?
It's not really a template. I mean, so the OM itself is not a template. The template part actually happens here. Actually, I will show you some kind of template here. So the template part happens here. The the cloud native, actually the OM runtime, the spec is actually runtime or platform agnostic spec. Although currently people kind of criticize us of make the spec look like a Kubernetes spec, but it is not. It is actually if you really look into it, it is pretty much a generic spec. And there is a Kubernetes implementation there. So we call it OM runtime. We have a OM basic Kubernetes runtime implementation that implement that spec on the Kubernetes. I don't know if that answers your question. Feel free to ask further questions to clarify things. I know it's the first time. We definitely will have some misunderstanding, and I probably didn't do a good job explaining everything.
Yeah, so basically, I was doing my school project for something of cloud edge architecture and some SDN. So it was like I heard of some few things that you just talked, and so I thought like it could be of some interest for me. So I just asked, nothing of much seriously.
Yeah. If you're interested to know more after this talk, we can connect offline and try to see if there are more we can do.
Yeah, thank you.
And especially as I mentioned again, the OM framework is very extensible in the sense that it's pretty much can taking anything on Kubernetes. Whatever runs on Kubernetes runs in OM. So it's pretty much, I'm pretty sure we can make something work there. Okay.
Yeah, so like I was just browsing on the few network models and all those things. So like, yeah, thank you so much.
Yeah, definitely. Yeah, network is one thing that you can see that we didn't really put a lot of effort on that front yet. So I'm very excited to have a mesh solution incorporated into our platform. Okay, so here's a little bit more concrete idea of how developers actually work on this platform. So there's one thing that I just want to mention in OM, there are three basically roles. They don't have to in real life. Probably it's one person, but there are like three roles. We define that one role is called app developers. Basically, it's the coders, basically programmers. And then there's the app operators. We define them as basically, you think of them as kind of SREs. I know they're DevOps, but you just put on two different hats. And then there's infrastructure operators. Infrastructure operators, you think of them as, in many companies, you have a so-called infra team. So those are the people who actually build the infrastructure for the company, and then for the developers and SREs to work on. So we have to kind of have this concept. And with this workflow, we basically say your developers will write your code and put them into the green ones is actually defined by the operator, by the infrastructure operators. They would define this. This is where the template comes. You have this template, you have this application code, and then you basically the real application code will be initialize the workload. That becomes the component. Then the component would have this SREs will put some traits and then put them into application configuration. This is the real applications. And then you submit that into the OM runtime and it will run. And also it will have this operational characteristics, not just a deployment sitting in the cluster. That's kind of the idea, a high level idea. In reality, we are also tweaking this a little bit because to be honest, because most people are doing DevOps, it's kind of hard to really clearly separate the developer and the operator part, especially when you get to the application configuration part. But anyway, I'll show, yeah, now I'll show you some real code. Okay, here's the real code. So all the let's see. So this is the most developer-facing part of this spec, which is called components. The components is essentially a templatized object for your workload. That's what I mean. But that's where again the template comes from. So here you can see this is the workload component, the kindness component. You have this workload here. Here is, I don't know if you can see my, oops. Here is really this pretty much looks like your Kubernetes deployment, right? This can be anything, but we basically for now it's embedded. Put it in a Kubernetes term, it's basically an embedded CR. It can be a component, a deployment, stateful set, or anything customized. CRDs basically. CRDs. You can define your own things, and you can put that into this part. That's what the component is. I don't know if that makes sense. Okay, and maybe when you put them all together, then that will make sense. And the reason we have this component is we can allow you to do anything you want. You can put any deployment. You can put in other different CRDs. For this example, it's called containerized. You just call it containerized, and you don't have to fill in all the things. That's where we think it's not developer friendly, because anyone who is new to Kubernetes will be really confused by so many different templates, labels, all these things, and they're actually hidden constraints there. That like the matching labels needs to be matched these labels, things like that. That if you are new, you have definitely get confused. So this allowed platform builders to build their own customized resource, and they can abstract out whatever they think is unnecessary. And for example, like here, the only thing they want to expose to the user is what's the image name, like where it is. This is in Docker registry. If you want your own registry, you put there, you put a replica, that's it. And underneath that, it can become a deployment, it can become a RESTful set, stateful set, whatever they want. So this is the abstraction part of the component. I don't know if I make it, again, I'll show you some examples to make it more clear. So the next thing is trait. So as I mentioned, the application configuration is what we think is an application, real application. And the component is the workload that we just mentioned. That's the developer's code, basically. And then in the application, you can have multiple components, just like any microservices. And then for each component, you can put in a few traits. And for each trait, it's just similar as the workload component before. In the traits, you basically can embed a CR. That's again oops, every time I click, it goes back. Embed a CR. That CR is just whatever you want. That's where you see there's networking, API gateways, the traffics. That's where the operators comes from. And each trait is basically a controller in terms of really Kubernetes way. It's a controller. So that you can have, that's where you have your you can have your developers writing the code, group them into your own workload. That workload is provided by the platform. And then the platform also provides a few already written traits, maintained traits. That traits, say here is HPA traits, right? It will tell you the max, min. I didn't put in a CPU threshold, whatever. You put in these things, and it will automatically scale your applications or at least for here is scale your component, like front end component. And then you can also have a API gateway, or we will have a route trait, tells you what's the host name, what's the path. Yeah, just like that. So now you have this application, you have your front end, is it configured? And then you can have your back end, you have your Redis, you can have your database, you can have your middle layer. Let's see if there's another one. And oh yeah, and then there's this, I think this actually is the most critical part of how it's extensible. That's the trait, that's the definition system. That's where I mentioned that the capability center part is how do you register all your capabilities to the system. That's where we call that a trait definition. It can be actually not just trait. It can be a trait definition, or it can be a workload definition. They're basic, and there's a scope I didn't mention. It's another concept that we haven't fully developed yet. So the registration is where anyone can register their capabilities into the system. For example, here the trait definition will tell you what's the name of this trait. It doesn't have to be this way now. It can be a much longer, a more readable name now. At that time, it will still have some. It's basically a CRD name. Now it doesn't have to be like that, and it can be a name. It will tell you what kind of workload it applies to, what kind of other traits that conflict with, and this definition is the schema. This is where remember you can define say containerized workloads which only have two parameters. That's where you can define the schema. And we actually in our implementation, we actually allow the user to define put another templatized. Basically, we call it's a Q language. I don't know if you've heard of that. It's called Q. So we allow user to define the real interface in a Q language, and the user can further abstract out all the details of this definition, and allow their developers to just fill in a few parameters into it. Yeah, again, I think I covered a lot of ground with very few with a few minutes. Maybe it's good to give you some concrete ideas. Let me see. So see if you can you see my, so I just pull up a web page. Yeah. I don't know if you can see that. You can see that. Yeah. So this is our implementation of the OAM. That's our reference implementation of OAM, and basically that's where the so let's see. Grab terminal here. Actually. So this is the really developer-facing part. If you can see I don't know if you can see my terminals clearly.
If you do enlarge it, maybe just by 2 bumps,
Okay, let's see if I can. How do I?
Yeah, if you try command the command plus.
Command plus, I tried. Oh, command plus. Oh yeah, does that?
Yeah, yeah. Okay,
so now we built up our referenced implementation called Kubivela. That's our envision. We know that just put an abstraction layer and the standard out, it's hard for people to really grasp the power of this abstraction. So we built our own system, and it's called Kubivela. And in that system, we have this concept called app files. That's where let me see if I can go back to the slides. Here. So we basically instantiate this part, to make this part really concrete, because the standard just defines this part. So we're putting more stuff on that part. And so the app file, you can see that. Let me just. That's where it's actually underneath it. It's application configuration, just as let me just try to, yeah, it is application configuration. Just because the application configuration, if you look at the schema, it's a little bit, it's YAML, and it's kind of verbose. We don't think it's really developer friendly. Developer don't want to write 200 lines of YAML just to describe their applications. So we simplified it a bit so that it looks like this. And in high level, you can see this is basically the name of the application. These are components. If you still remember, components basically are the user's services. And then this is one service. We abstract out a few things like the image here, and build is the source to image. This is actually not source, it's going from Docker to image. And then these are the traits. And to demonstrate a little bit, let me see if I can. So we can call it up. See if so this is basically yeah, we're building building up this Docker image, building up the image, and then we are going to translate that into applications, components, traits, all these things. At the end of that, let me show you. Okay, so that this works. Let me show you this. So for this to work, we installed the application configuration controllers in the Kubernetes.
And, Ryan, just to quickly interrupt.
Yes.
If you don't mind doing the control or the command plus a few more times, there's a few folks that can't.
Sorry. Can you see that better now?
Yep. You know, the answer is that it's never big enough. It's kind of a funny.
Oh,
but yeah, no, I think you're beautiful.
Is it a little bit better?
Yeah, totally.
I can actually make it even bigger. So actually looks like I can do it even more. Okay, let's see if it's possible. So let me go back, since people haven't seen this. So let me go back to this app file. So app file, I think the concept comes from a Docker Compose. We feel like Docker Compose is something that is actually pretty user-friendly, but unfortunately, it's not as popular as it didn't win the containerized war though. But we still like it. So we kind of revive it and kind of get this idea. So let me get going back again. So the idea is you have this application name, you have each services. We call it service instead of component because we want it to really sound like microservices. So each one is we call them a service. And inside that, you can define a service. You can basically it's image, build to source to image, and a few really common things to a command port number. And then the key thing is those are the traits. Each trait, we have a definition somewhere. That's where the definition, right? Let's see if that we have this. Yeah, okay. So I'll just show you a few trait definitions here. For example, you have this route trait. You have this route trait. Yeah, so here's an example of this route trait. You have annotations, create time, blah, blah, blah. here's what I mentioned, right? You have apply to workloads. What kind of workloads it applies to? It will tell you the web service. Definition ref this is the CRD name. Basically, this is the real CRD name. That means that the route we have a controller behind that. We have a template. Oh, this is not very user friendly here for some reason. This is how you because we have this template defined here. That makes this route. Let's show you this. Here, that makes this. That basically defines this part schema. So the previous template part is the queue part. Maybe I should have another. Oh, too many, I guess. This have the same. Oh, this doesn't have the same font size. Okay, I cannot really show you together. So now, for example, let's redo this. Because previously I just deployed the application. I don't have the. I didn't define ingress, so you cannot really access this part. Now let me add a route trait to it, and then just basically upload it again. I don't know who copies what. I think waypoint use exactly the same verb. They call waypoint up. So we are kind of similar there. So
I think
yeah.
It's probably from Vagrant. Vagrant up was pretty sort of helped popularized. I think popularized the verb up, and then Docker Compose. Docker Compose kind of did up and down, and
I see. So yeah, I guess that solved the mystery, because when I saw waypoint, I was like, it looks exactly the same. I don't know who copies what. I guess we both copied from Docker, and they're more. So now let's see if I can curl this thing. Do I have a curl command somewhere? Let's see. So putting out. Okay. Let's do this. See my front end. I need to get my Kubernetes ingress front end IP. Mm-hmm. Just bear with me. Okay, I think I got it. Let's see if that works. And what route is I guess I could. Okay, hello world. I mean, it's just the basic hello world. So yeah, again, this is really a very simple example. Let me see if I can show you a bit more. Yeah, the rest, I think, to be honest, there's some technical glitches. I know that is waiting for me, so I'm not going to venture into those and the live demo. I'm still debugging these things, but just general idea, you can see we can also put in auto scale. You can put in scalar. We actually have an auto. You have a rollout too. Like when you want to upgrade, these are the things you can put onto the applications, then it will let the controller automatically do this for you. The key part is, ideally, these are defined by the application platform builders. So platform, that's where the platform builders, at least in our view, can make their platform attractive, is that they have very powerful operational controllers, basically. They can execute very complicated logics and seamlessly pull off upgrade. And the developers, all they need to do is just look up their platforms builders capabilities and fill in those really simple traits, and things would work out. That's the basic idea. Yeah, I think that's the end of my
Nice.
demo. I don't know if I have anything more in the talk. Just let me take a look. Yeah. So for the community, so OAM is a joint project between Microsoft and Alibaba Cloud. So we are working with Microsoft, as I mentioned. So we defined the AppConfig part, but that's not part of the OAM spec yet. So we are working with them to get a more developer-friendly spec into the OAM. And the Crossplane, I don't know if you've heard of that. We actually collaborate with Crossplane. The OAM runtime is really part of Crossplane now. But the Kubevela is not, because we want to write just with the OAM runtime itself. Again, it's not very useful. We need to add more developer layers, make it a real full-fledged reference implementation. That's why we built up this Kubevela. I think that's about it. Yeah, so we have some community meetings. We have specifications, runtimes. Yeah, all these things. We have all these things. Okay, thank you very much for letting me kind of ramble here for like 30 minutes.
Yeah, no, right. I've got more questions than we have time for, actually. But before I ask my questions, does anyone else on the call have comments or questions?
A pretty basic one, I guess. I didn't understand why did you need to define traits and scopes differently? Like,
so I think I didn't even. Yeah, first thing is I don't think I even mentioned scope. You probably either have looked at the OAM already or scope is.
Yeah, I was going to the docs while you were presenting. So.
I see. Oh, great. So the difference between trait and scope is application level, or it can go across multiple components. So for example, we have a VPC scope, or virtual private network scope, or something like that, so that multiple components can reside in the same VPC. And so that scope needs to go across multiple components. And trait only applies to one component. So that's a big difference. And we are thinking of putting a application level scope too, so that we don't have to put scope into every trait, every component. Sorry. Does that answer your question?
Yeah, but yeah, it makes it a bit clear.
Oh, okay. Yeah. There's if you look at our community issues, there's one strong request to make a scope application level entity instead of component level entity. And actually, many of the network stuffs, I think, traffic stuffs, are actually scopes instead of traits. And authentications, right? Those things are mostly scopes. Any other questions? Good question. Any other questions?
Hey, I think I have one. Hey, hey Lee, and yeah,
Go.
it was a while. Wasn't able to join, but yeah, hopefully you have. So Ryan, I joined in the middle, so just ignore me. So, is it kind of templating language like Helm? And if not, what's the difference, like in this case, to describe?
So, are you asking like a Kubevela, or you're asking OAM? OAM, actually, let me see if I can give you a more concrete idea, because here, just let's look at the specification. So for the specification, For the specification, it's really just look at this. Say a component. It's really just a high level define of the object. It's not even YAML or JSON. Although we assume many when they implement that will use YAML or JSON, which to us is pretty much equivalent. The spec is really just the object level definition of what each object will look like, what are the fields inside that. That's the OM spec alone is like that. In terms of templating part, that's on top of that is, as you can see, and you saw our application. Actually, let me show you this. Let me show you this. I spell right. Yeah. So remember, we have this app file, right? So this file, as I mentioned, this is equivalent to application configuration. This is more. This was heavily templated. It's equivalent to that. And this one is the real application definition. You can see that it has the. This is what we in the backend basically translated into application definition. It's basically it's a in this Kubernetes world. You can see it looks just like normal CRDs. It has components. Now you can see the components has express server scopes. We actually putting a health scope here. Traits. This is the route traits I mentioned. You have these specs, and then the test status, workloads. Yeah. So application configuration in our implementation looks like this. And to make it less verbose or more user-friendly and provide this power of templating power, the abstraction power is, again, because we allow the platform builders to build a very powerful controller, basically. I call it controller, you call it CRD, you call it whatever operator. Yeah, but there are many times in the design phase, there's a tug of war between how powerful you want to provide and how simple you want to provide. You want to provide an Apple thing, right? Just one click does everything. Or you want to provide whatever the old school Windows thing. You can do anything you want. So how do you balance this? Is we want like use developer the platform builders to build a very powerful one, but also give them the option to expose that as a very simple interface. Then they can tune in there whatever they want to tune. They can expose the whole thing too. It's up to them. Okay. I don't know if that answers your question.
I think I will still need to check more in documentation, but I think it's
some high level idea. Yeah.
High level. Yeah. Thank you. Yeah.
You're welcome. Good question. Any other questions?
Nice. We're right at time. Ryan, I have lots of questions for you. In the best of ways. But given that we're at time,
and we can also connect offline too.
Nice. Ryan, thanks a bunch for this. This has been really nice. It's really good to be introduced to the project and see, to understand the vision and scope of the project, the purpose for it, without having to try to decipher that from written word on the web pages.
Yeah.
And it's evident that there's, at least to me, that there's a few there's a few concepts or problems that are at the core of what you're trying to solve, and it's some of that has to do with, I know it's a broad term, but some of that has to do with just UX. Some of that has to do with the acknowledgement that it's actually I've talked oh man, boy, I bet, you know what, let me not say a number of things. I think a lot of things that you said resonate, and some visions that you guys have resonate. I've spoken on this subject any number of times. And so, yeah, there's, while I think that some might look at this and say, well, but aren't you just kind of redefining stuff that's already in there? Can I just use my Kubernetes manifest for that? Couldn't I capture that info in an annotation or somewhere else or something. Like the thing is, if you look at the problem long enough, it's a big enough problem that it's not addressed, or like, no, those annotations are not enough, or no, there's a number of concerns. And moreover, if you break it down the problem and you say there's this persona, that persona, that persona, there's three that you talk about in here, and then there's the network engineer, there's the service provider network engineer, there's the people trying to do network function virtualization, there's people trying to do operators trying to run service meshes very well, and they go very deep. There's those that are trying to do serverless and function things, and they need different day two concern, blah, blah, blah. Like it's a massive surface area potentially,
Yeah, definitely. Yeah, definitely.
So this is exciting. I was just leading the CNCF's SIG network call yesterday. We were talking, I mentioned OAM, and I mentioned the fact that you'll be here doing this because half of what our conversation was on that SIG network call had to do with really just this problem statement that things like SMI are somewhat related to this, but SMI's surface area is about yay big.
Yeah.
And so
yeah, I think we have a demo that also maybe not demo. We are working with SMI too. We try to incorporate SMI into our system too. We have something semi working there, but yeah, it would be great to collaborate furthermore. Definitely, at least get something really working there to round up this whole feature, because you can see we don't have enough network features, traffic features there.
Yeah. Well, I will definitely reach out. Myself, I'm an SMI maintainer, and we are trying to figure out what to. Yeah, I'm trying to. Yeah, there's a bunch of things to talk about, so I won't bring them up. But
sure. Yeah.
Right.
Thank you very much.
Yeah. Thank you much, Ryan. All right. Fair enough. So we're just at time, everybody. There is. Well, now I lost track of the meeting minutes, but there's only one quick item to call out in the meeting minutes probably, and there's a number of things for us to chat on, all of which can wait. Only one of which we should call out. And Ruth, do you want to say a quick word? If Ruth is on?
Ruth is not on the call.
Oh, okay. Kalechi, do you want to say the thing that Ruth would have otherwise said? Which is Ruth has wrote up a talk proposal for FOSDEM, and she's asking for some feedback. So if anyone has feedback to offer, I think she's soliciting it. Other than that, we'll so very briefly, Josh and others on the call that are focused on Layer5 NG, we do have the 2021 goal. So Josh, we should talk about meeting tomorrow and set up a time. And other than that, so like I said, we won't meet in the community meeting next Friday, but we will have the regularly scheduled other meetings throughout the week. So with that, thanks everyone, and thank you very much, Ryan. See you guys all next week.
See you.
Yeah.
Talk to you later.
Yeah. Thank you for the presentation.
Thank you for
Bye,
having me.
everyone.
Thank you.
Bye,
Thank you.
everyone.
Bye.
Thank you. Bye-bye.
All right. So quick review on the course and kind of what we talked about, and then we'll jump into kind of the exam.